Alright, now I'd like to talk about the three laws that allow us to manipulate logarithms and to do more complicated calculations with them. And the first one I'd like to talk to you about is the following. So if we have log of base A of b times c, so this is a multiplication inside the logarithm, then that is equal to the log A of b plus the log base A of c. So this is, I'd like you to take note that this is all the same base that we're working with here. So we can split this into two separate logarithms. So that's an important rule that you need to memorize, and I feel duty bound to show you the proof for this, but I am not going to be asking you about it. So proof, just for your satisfaction. So if we say that x is equal to log the base A of b and y is equal to log in the base A of c, so that this is all the same base for our logarithms, then we know that that a to the power x is equal to b and a to the power y is equal to c, because that's our general equivalency with our logarithms. And therefore b times c is equal to a to the power x times a to the power y, because I've just substituted those two. And we know that if we multiply two things with the same base and we're multiplying and they've got exponents, then we just need to add the exponents together. So that's a to the power x plus y. So that's the same as what we've covered before with our powers. Alright, so now we need to bring into play our classic equation that we've met elsewhere. So we know that b to the power x is equal to y is equivalent to the logarithm base b of y is equal to x. So this is the same letters but different meanings. So this b isn't necessarily the same as this b here. But this is just our same equation that we remember. And I'm going to mark these different things in different colours so that we can keep track of them. So I'm going to make a y, circle that in blue. And what's our y equivalent to in this expression here? That's our BC. Okay, and now let's circle our base in red, B. And here, what's our base? We're calling it A. And finally, our x value here, so in this expression, we're calling that x plus y. Okay, so now we can use this. So that means that the log of A, so that's our base in this story, is equal to, the log in base A of b times c, so that's our y, is equal to x plus y. So that's our green, what we call the x value in this. Okay, so I'm just using this equivalency to change from this into a logarithm. Okay, and then we know that x is equal to log a of b and y is equal to log a of c, so we can just substitute those in there. So log a of bc is log a of b plus log a of c. So there's the proof. I just feel honor bound to show you that. You don't have to remember it, but you could maybe reconstruct it yourself if you manage to forget. So now let's just work through an example to prove to you that's true. So let's imagine we've got log of 10. So I haven't written a number for the base here, so let's assume that, so that means that it's log in base 10. So we've got log of 10 plus log of 100, which we're saying using this equation is the same as log of 10 times 100. which is log of 1,000, and 1,000 is 10 to the power 3, so that is equal to 3. So log 10 of 10 to the 3 is equal to 3. Or if we do it the other way, so log of 10 plus log of 100, so that's log of 10 to the power 1 plus log of 10 to the power 2, so that's 1 plus 2 equals 3. Okay, so this comes out the same. So the thing I want you to remember for this is that the log of b times c is equal to the log of b plus the log of c, and that's quite reminiscent to what we saw with exponents.